Hello everyone. So today we are going to discuss a problem that is generally asked in machine learning system design interviews, that is harmful content detection. Uh, Before starting the video, I would like to tell you what I'm going to cover in this video. So the first topic would be the objective, that what we are going to build. Second would be the input output of the system. Third is the data engineering part, where I'm gonna tell that what data do we have. Fourth is the feature engineering part, where I'm going to cover about like how to convert this data you have into features so that your model can understand. Fifth would be the model development section. The model development section would include like why are we going with a particular model, what are the advantages of it. Sixth would be the evaluation part. Evaluation will tell you that after you build the model, how will you evaluate whether a model is good or bad. And the seventh and the last part would be serving. In serving, I'm going to cover that how are we going to serve this model to the end users. Coming to the objective of the system. So the objective is to build a system where a user can post and we have a service which tells whether the post is harmful or not. Now the post could be harmful in like various ways. It could have like violence in it, for example bloodshed or anything like that. It could have nudity or sexual content in it. It could have like illegal activities like drug trafficking and all that. Then it could have hate speech. Then it could also have something like self-harm. So all these things could be considered as harmful contents. Now the user in a post, the user can just write a text, or he could just add text plus image or text plus video, and other users can comment over the video, plus other users can report a post as well. So these are some of the constraints that I'm already defining. There could be other constraints as well, but to start with, let's take this. So the user can report as well, and along with that, the user could comment also on a post. The comment could be related to the post, or it could be like that this post is harmful, something like that. And for data labeling, we initially consider that we have human annotators who are gonna tell that, hey, whether the particular post is contains violence or not, whether it contains hate speech or not, because we would need data initially to train our model. So that's why initially we are considering that the fact that there are human annotators who are gonna rate a video and tell that whether a video contains violence, sexual activity, illegal activities, hate speech, or self-harm. And this could be a label like, so for example, if the video contains both violence and self-harm, so the user could be just say that, okay, it contains violence and it also contains self-harm. So these are some of the constraints and the objective that we are going to solve. Now coming to the second part, that what is our input and output. So if you see, the input is a post itself and the output is a probability. So let's consider this as a system. This is our harmful content detection service, which gives me a probability score, saying that if this probability score is high, then the post has to be immediately deleted from the platform. Deleted. Okay, so input is a post and output is a probability score. Okay. Now coming to the third part, that is data engineering. Now what data do we have generally? So think of the examples that you use on day-to-day basis. So for example, if you use LinkedIn LinkedIn has something like, hey, someone is posting and someone is commenting over it. So there is something related to a post, and then there is something related to a user. All these details are there. So let's deep dive into it, how it's going to look like. So to start, let's say we have a post. So the post could have data like textual content in the post, then it could be image or a video associated with the post, then it could be the comments over the post, then it could be the timestamp at what time the post got posted on the platform. Fifth could be the author ID, that who posted the post. So these are some of the things which we would have with respect to a post, which somehow we are going to use it to develop our features. And what data other we can have? We can have other data as well, such as related to user. So for example, if a user is there, he would have his age, then he could have like how many number of violations he has already carried out on the platform. So for example, if he is posting only content which is harmful in nature, so we would always keep increasing the count. So we would know that, hey, in future that this guy always posts harmful content. So we would make sure his ID gets deleted. So number of violations on the platform. Third could be the gender. These are some of the things. There would be other data as well, but if you think that what is required to build such a service, you will feel that only this much content is enough right now to think of making such a service, which helps me in detecting harmful content. Okay. Now coming to the fourth part, that is feature engineering. Now feature engineering means that somehow I need to convert this data into something which my model can understand. Okay. So initially I told you that post had this data, right? So let me just copy paste this. Okay. Now we know that, hey, this is textual content, but a normal textual content, can we understand whether it's a harmful thing for us or not, unless we have the contextual meaning of the text, whatever he's posting. So for understanding or getting the contextual meaning, we need a model which gives me the contextual meaning, right? And that too in numbers. So we need the contextual meaning. This is one challenge. And second challenge is that everything should be in numbers, because my model won't understand like English, Hindi, or whatever language the guy has posted in, right? So for that, if we think, we already have pre-trained models like GPT or BERT, which will give me the contextual meaning of whatever sentence I am giving in, right? So why don't we just convert this textual content into a embedding vector, which gives me the whole meaning of the sentence, so or a sentence or whatever that guy is posting. So for example, so just to explain you better, what we are going to do is that this textual content will be passed through a pre-trained model. The pre-trained model could be like BERT or GPT-2 or any open source model, open source transformer, which could convert which would convert text into a contextual vector, right? So let's consider that we pass this textual content into a pre-trained model, and this pre-trained model gave us a vector which is of 512 dims, which understands the meaning of the sentences that this guy posted. Okay. We don't need to train such models because these models would be out of scope of this video. So we would generally go with a pre-trained model, which gives me the contextual meaning of the textual content. Second is image video. So for image video also, if you think we need something which helps me understanding the contextual meaning of that image. So for example, if someone is posting a image which has a lot of bloodshed in it, right? So I need such a model which helps me give numbers in a form which explains that, hey, this content is related to blood. So for that also we would go for a pre-trained model. So pre-trained model like clip, right? So for images, let's say for image, there would be a model like clip, and for video, there would be another pre-trained model, which could be converted into a vector which is again of 512 dims. But you need to understand this 512 dims represent the contextual nature of that particular video or image. Like through that vector, the model can understand, hey, this is related to somewhat blood, or this contains like something like really harmful. Okay. Then coming the comments over the post. So generally what happens is that if, let's say, some guy has posted a video, and if it's harmful, then generally if you would see the comment section of that video, it would be there would be users who would have commented that, hey, this contains some sexual content, or this contains a lot of self-harm stuff, right? So again, we need to take these comments and convert it into a proper features. But again, the comments are in form of text only. So again, what I need is for every comment, for every single comment, I'm going to pass it through a pre-trained model like BERT or GPT. And this is going to give me a 512 dim vector for every single comment, right? And what we can do is that we can take average of all the 512 dim vectors for all the comments. So again, this will just give me a single vector which will represent, okay, all these comments that are there in the post, this is what it means numerically. How are we going to use it is something that we will see in the future. But we need to understand that initially the first task is to convert it into something which the model can understand. Okay, now coming to the timestamp. Timestamp is again something which is not useful for us, so there is no point in converting into a feature, and author ID is also not useful for us for now. Now coming to the part of users. So I told you that, hey, we had the user age, we had the number of violations, then we had something like gender. So these features could be also used, but again, they would be just side features. They wouldn't be the main features that would tell whether a post is harmful or not. So these are just kind of a metadata information that will be used in our model. So for age, what you can do is that generally you use bucketization plus one hot encoding. So what does this mean? Okay. So see, age could be divided into categories. For example, someone is from 10 to 18, then 18 to 26, then 26 to 34, 34 to 42, 42 to, let's say, 60. So it could be divided into categories, and let's say if a user is from one of that categories, what we are going to do is that we are going to just fill that number with 1. So what does this mean? So let's say if a user is of 19 years old, so his vector would look something like 0, 1, 0, 0, 0. And this one represents this particular bucket. Okay, so this is bucketization plus one hot encoding. Now for number of violations, the best thing is you could use a log score, log of 1 plus number of violations. So this will be just a single number, something like 0.35, 0.32 on the on the basis of number of violations the person is doing. And then it comes gender. Gender again could be one hot encoded. There could be just three categories: male, female, other. All these information, these two information are just metadata information that we are just using to train our model. Because again, the age and gender won't much matter to tell whether a model is harmful or not. But just consider that this is the metadata information that we are using. If we don't use it as well, it wouldn't be a big thing. It wouldn't change a lot. Okay, so how are we even going to use it? See, we had a textual content embedding vector that we got from a pre-trained model that was 512 dims in size. Then we got a image comma video which was again 512 dims in size, and comments also 512 dims in size. Okay, and let's say all this stuff that we have, again it's just like, let's say 8 dims, 3 dim and 1 dim. That would be roughly 12. So 1724 1536 15. So roughly, if you, so what I mean to say is that what we are going to do is that we are going to concatenate all these features. Concatenate all the features. Okay, so what does this mean? This 512 dim vector plus again 512 dim vector, again a 512 dim vector, and then a 12 dim vector. That would be roughly a 1548 dim vector. Okay, so these are all the features that we have got, but somehow we have to use them to develop a model which tells whether a post is harmful in nature or not. Okay, so how are we even going to do that? So let's think of something. So let's come on the part of model development now. So in model development, see, if you think that, hey, I can develop models for every particular task. Here, every particular task means that, hey, whether my post contains violence or not. Hey, my post contains sexual content or not. So for every particular category, you say that, hey, I'm going to develop a different model. If you go with this particular thing, you know what is the problem. The problem is, for every particular thing, you need a different kind of data set. You have to make sure that data set which is going in violence only have that labels which are related to violence. Okay, and then the same stuff here, same goes for all 5 categories. Then the second problem is that the training time would increase, because you are training 5 models. And if you are training 5 models, the biggest problem that would come is maintenance problem as well, right? So we can't go with 5 models. We need to think of an approach where we go with a single model which does the task of harmful content detection for me. Now for this, let's choose a model that is used for multitask classification. Now what does this mean? So such models are that models which have some shared layers, and after shared layers, for the problem that you are solving, it has individual heads. So for example, let's say if we are going to solve the problem of harmful content detection, the shared layers will try to understand whether the post, whatever it is it aggressive in nature or not. Okay, and individual heads will try to solve the problem whether, whether it contains violence or not, and it contains self-harm or not. Okay, but how exactly the model training data would look like, and how exactly the architecture of this model would look like. So let me give you a basic understanding of that. See, what we had was a feature vector which was of 1548 dims, right? Which already came from pre-trained models, like that contained image, text, then it contained your comments and some metadata info, right? Now, I already told you in the video that we have human annotators who would annotate that, hey, the video is harmful and what kind of harmful it is. So for example, let's say the human annotated something like this, 10001. So it means here one means it's related to sexual content. Okay, here this particular index means that it is related to self-harm. It would mean related to illegal activities or drug trafficking, something like that. It would contain some other category, and it would contain some other category. So you see, your input is something like this and your output is something like this. And you see, in output, we are just trying to calculate this probability that, hey, whether the post is contains sexual content or not, whether the post contains self-harm or not, whether the post contains some other category or not, right? So this is something our data is going to look like. Okay, now there comes two problems. So the two problem is the problem about imbalanced dataset. Imbalanced dataset. See, how are we going to solve this problem? See, there could be two things. One thing is that the data related to harmful content is very less on your platform. Initially, that would be the case. And the only solution for that kind of problem is that you dig deep more into the data and try to get more data as much as possible. So that is the only solution to the problem. But there is second thing also. In this categories which we are defining, there could be thing like there is very less post. There is less number of post which has self-harm in it, right? So how do we take care of such things that my model is able to understand that, hey, the post can contain self-harm also? So to solve this problem, what we are going to do is that we are going to give weightage to every particular category. So for example, you know that self-harm data you have less, right? So you would give a different weightage to it. So you give a weightage score of 10, right? Then for violence, you know that you have a lot of data, so you can just give a score of 2. Then for let's say you have nudity or sexual content, you can give a score of 5, right? So for every particular category, you would give a different weightage, and all these categories could be all these scores would be used whenever we will calculate the loss in the model. Now, coming to the part of loss, first thing is, how is this model going to look like? So let's try to understand. See, initially we have roughly 1548 features that are going. So initially we have some shared layers. Now these shared layers could be just deep layers. So for example, 512 neurons. Okay, and all the features are going in, and a ReLU activation function. Okay, so this could be 512 dim. Then there could be another hidden layer which is again deep, which could be of the size, let's say 256. Okay, these are the shared layers whose task is to just understand whether, hey, whether this post is even aggressive or not, or just the common understanding of whatever content we are giving. But then we can have individual heads. Now these individual heads which will be there, they are individual neural networks. Now, how these individual neural networks will look like, let's see. So we had a 256 layer neural network here, right? So then what we can have a 64 a layer with 64 neurons in it, and then we can have another layer which has just one neuron in it. Okay, and then what we can do is that we can apply sigmoid to convert the output of this layer into a score. Now the thing is that you need to understand that why are we not going with softmax and why are we going with sigmoid. See, the thing is that here we need to tell, the model is trying to tell that, hey, how much confidence do I have in saying that this post contains sexual content or not. So let's say if model says I have 46% score, 46% confidence saying that, hey, this post can contain sexual content, right? But softmax is used for like binary classification or just like yes or no. But that is not the problem that we are solving. The problem that we are solving here is that we have 5 categories and there could be 2 or 3 categories at a single time, right? So that's why at the output layer, the activation function that we use is sigmoid. So to get a probability score out of it. Okay, so now you see every particular layer will have sigmoid at the end, and then it will have a score, output probability score. And once you have this output probability score, what you need to do is that you know that your output column look something like this: 1 0 0 0 1, just for the example I am giving you. And now let's say your scores are something like 0.46, 0.2, 0.1, 0.3, and let's say 0.8. Okay, so now basically you wanted to predict 1, but your score came out to be 0.46. So you understand that here we have to use a loss function of binary cross entropy. Okay, and the other question comes is that, hey, if we are using this loss function, then how is the total loss calculated and how this backpropagation works? So let's discuss about that. See, total loss would be something like W1 into L1, W2 into L2 plus W3 into L3, W4 into L4 plus W5 into L5. So what does this mean? See, L1, how are you calculating? L1 you are calculating using this, applying this binary cross entropy of these two things, 1, 0.46, right? Once you get this, then I told you that for every particular category we will give a different weightage. The weightage is different because we want to penalize the model more if a particular category is less. So to inform the model that, hey, don't perform this mistake again in the future because we have less amount of data available. So that's why every particular loss category would have a different weight associated to it. So for example, for violence, as I told you, for self-harm we had a score of 10. Okay, so 10 into L1 plus, let's say for this had a score of 2, so 2 into L2 plus then and so on, it goes like this. Okay, then comes the question, hey bhaiya, what is going to be even updated in the model? What weights are exactly going to get trained? See, on the basis of the loss that you calculated here, right, your neural networks, which are individual neural networks for violence, for self-harm, for nudity or sexual content, these are updated. okay, the weights that you had here. And once you get the total loss, all these weights which are in the shared layer, they are going to get updated. Okay, then you can have asked this question to me ki bhaiya, are these pre-trained embeddings going to get updated? The answer is no. See, the embeddings which you are getting are already from a pre-trained model, which have been already trained on such data. So you don't need to tell that models, hey, you are telling the wrong data or you are telling the correct data. We are already thinking that whatever it is giving is correct to us. What we are training is this particular layers on these particular heads. Okay. Now, coming to the part of, so I think here the model evaluation, the model development part gets over. Now coming to the part where we have evaluation of the model. So see, evaluation consists of two things. First thing is offline evaluation. Second thing is online evaluation. So see, what is the basic difference between them? Offline evaluation means that, hey, your model is not live right now. You have just made the model. You have historical data present with you. And on the basis of that, judge your model. Can you tell whether your model is good or not? Okay. And online evaluation means your model is live and users are using it. Now, according to the feedback they give, is your model is good or not? Okay. So let's take the part of offline evaluation right now. See, for classification, we generally think that, hey, we can just draw the classification matrix and get the accuracy, precision, recall, all that scores. But is it good or is it not good? Let's try to discuss about that. So see, this is the classification matrix. The classification matrix looks something like this. Actual, predicted, true positive, true negative, false positive, false negative. Okay. So let's say if you say that, hey, for telling for offline evaluation, let's use this accuracy thing. Okay. Now, why I don't want to go with this accuracy score? Now you know that the accuracy score is calculated by true positive, by true negative, by false positive, false negative, true positive, true negative, all these scores. Right. Let's take a very simple example. Okay. So let's take the example where roughly the number of harmful posts on your platform are 10. Okay. And 9, other than that, there are 970 posts. Okay. And your model said that 10 harmful posts are there and 970 posts are unharmful. And then it told some false positive and false negative posts, and total posts were 1000. Okay. So your score would come out to be 980, 10 plus 970 by 1000. So it would come out to be roughly 0.98, which means it gives an accuracy of 98%. Which is, again, if you think this particular matrix is does not even tell whether your model is actually good or not, because of the imbalanced data set present in your system, right? Because the true negative values are really high in number, so we can't go with this this particular accuracy score. We need some other things. So think of something like precision. Okay, now what is this precision? Precision is calculated by TP by TP plus FP. What does this mean? Out of the harmful posts that I am telling, how often the posts are harmful, right? So let's say there were 20 posts, consider the fact that, let's say your model said 7 posts are harmful, which were really harmful. Okay, that is like true positive. Okay, for 20 posts, it said that hey, this was actually not harmful, but it came out to be but my model told that hey, this is harmful. Okay, so false positive means that the post was actually not harmful, but my model said that this post is harmful. So if let's say if we try to do that, then it comes to be 7 plus 20. That comes out to 7 by 27, which again comes out to be low quantity. But if you see, this score is bad. But again, this matrix could be used, that if the precision is high, then it certainly means that out of the posts that we are telling to the end user that these are harmful, that means that we are telling the correct number of posts, because this false positive score would be less at that time. All right, because for this to be high, for precision to be high, this denominator has to be less, right? So one matrix that we can use is precision. Now coming to the second matrix, that is recall. So recall, how we calculate recall? True positive by plus false negative. So what does that mean? So false negative means that actually the post was harmful, but my model said that hey, it is not harmful. Okay, actually the post was, let me explain you, actually the post was harmful, but model said no to it. Okay, so let's take another example. Let's say we had 7 posts that were harmful, and then we had 3 posts told by our model that hey, they are harmful, but actually they were not. So false negative comes out to be 3. So this score comes out to be 7 by 10, which comes out to be 0.7, which again is a high quantity, right? So is this good or is this bad? Now we need to think that. So again, this is something which you can't just say that hey, high recall score means that hey, the model is good. So at the time when you are calculating the recall, we want that both recall and precision should be high. Generally, if a high recall score is coming, but if your precision reduces, then again the model becomes bad. Okay, and what does this recall even tell? Recall tells out of all the harmful posts in your system, how many actual harmful posts you were able to tell. Okay, so we need another criteria which helps me in evaluating our model. So for that, what we can do is that PR AUC curve. Now what is this? See, the thing is that let's say if you are saying let's say you had this violence head in your neural network which said a score of 0.9, that hey, I am 90% sure that this post contains violence in it. Okay, and you have given a threshold score of 0.9. So this post would be marked as something which has violence in it, and it would be deleted, right? But let's say if you decrease this threshold score, you make the score as 0.8, and when you make this point as 0.8, you would see the number of true positives, true positive, false negative would change, right? So it totally depends on the threshold that you are giving to every particular head, right? So we need something which helps me in drawing or calculating that how my model behaves with respect to threshold. Okay, so what we are going to do is that for every threshold score, let's say from 0.2 to 0.3 to 0.9, for every particular score, we are going to calculate this precision and recall. So it could be something like recall and precision we are going to calculate. Okay, and then what we are going to do is that for every particular score, we are going to plot them on this graph. Recall would be represented by x-axis and precision would be represented by y-axis. See, generally what happens is that generally for a good model, for a good classification models, the curve should something look like this. The precision should remain high, right? So what you want is that precision should remain high and the recall also should remain high as I decrease the threshold. Because if you are decreasing the threshold, what will eventually happen is that you would take in more number of posts, right? Because if you are saying that, hey, the threshold score is just 0.5, so the false negatives, false positives would eventually increase. So you don't want that your curve should just as soon as you increase the as soon as you decrease the threshold, there is a sudden decrease in precision. Because if that is happening in your model, it means that your model is bad, right? Because eventually the recall is going to increase. Because you see how recall is calculated. Recall is calculated by this formula, true positive by true positive plus false negatives. So when you are decreasing the threshold, what you are saying is that, hey, if I miss some post, that would be also marked in true positive now, right? Because you have already decreased the score to 0.5. So if you are missing some post, so true positive would eventually increase. So recall is eventually going to increase at whatever cost. But you have to also make sure that the precision remains high. And the thing is that what we eventually do is that in real life, how this, for a good model, how it looks something like this. This is how it something like looks. The curve something looks, precision recall curves look something like this for real life models, good models. Okay. The thing is that you need to also understand that we need something as a base classifier to tell whether my model is good or not. So what do I mean to say here is, see, let's say you make a random classifier. Now the task of this random classifier, this random classifier doesn't have any brain. It has no training, right? So let's say let's take this data where we have 100 posts, 1 harmful post, and 99 safe post, means no harmful, nothing, no harm in that post. Okay, now if I ask you this question that, hey, what could be the average precision? So the average precision could be 1 by 100, that is 0.01. Now what does this mean? Let's take this example that like what we want from this is that how bad a particular model could be. Like we want just the worst, that what should be the worst criteria for us, because we are trying to train a model which is better than that worst criteria. So if let's say you pick up 100 posts, what are the chances that this model is going to tell that, hey, this post is harmful? So the chances are 1 by 100, right? So this is the precision. Okay, and once we plot this score, we will get, and once we plot this precision, so you see recall here means that for how many number of posts we go, from 0 to 1. For let's say from 1 to 100 we go, for how many ever we go, the precision is always going to remain the same. So this is the base classifier. and the area under this is base classifier precision recall area. Okay, now my task is that whatever area I am getting, right, this area should be better than this particular base classifier precision recall curve. Okay, so see how it works is that, let's say you got your PR curve, right, and let's say you got that as 0.30. okay, and your this particular score was 0.01. so if you calculate that, it would roughly come out to be 300x, something like that, 30 by 13200. So it, sorry, 30x. So it means that my model is 30x better than a random classifier. Okay, so you understand there are three matrices that we can use for evaluation: precision, recall, and third is PRA, precision recall area under the curve. Once the area under the curve is high, it means your model is good. Okay, now coming to the online evaluation part. See, for online evaluation, first thing is that I told you that we will give the user the features of reporting a post is harmful or not. So the best criteria could be the number of posts system detected as harmful, by number of posts system detected harmful plus the number of reports. Okay, this is one of the criteria that we can use. Second criteria that we can use is appeal. Appeal means, so for example, let's say there were 10 posts which were said by our model that, hey, this post is harmful. Okay, let's say there are such 10 posts, and for and let's say the user appealed that, hey, it's not harmful. So if it's if someone is appealing, it means that it would go through a human again. The human would finally confirm that whether the post is harmful or not, right? So what we can do is that total number of appeals by number of harmful posts detected in the system. If let's say the number of appeals are really high, it means your model is classifying wrong post into harmful content, right? So number of all harmful posts detected by the system. But now comes to the end part of this video, which is the serving part. Now see, for serving part is as essential as the whole video, because we need to somehow give this whole model to the end users. Okay, we know that what will be coming as an input, a post is coming as an input. Okay, we have a harmful content detection service. Okay, but as soon as a post comes, the first part is converting that into features. So feature extraction. Okay, second part of it would be to ask my model, hey, is this even harmful or not? So I have my trained ML model here. So basically what my service is going to do, this service is going to convert this into features and ask my model, hey, whether this post is harmful or not. But you think there could be two scores. Let's say there was this threshold score we set as 0.9. Okay, if my model says there is some post which has a score of 0.95, this video has to be immediately deleted. But let's say there is a post which is 0.8. which gets a score of 0.8. What should we do for that kind of post? So the simplest service is we can make two solutions for it. One is a demoting service, and one is violence or harmful content enforcement service. So what does this mean? See, if the threshold score comes out to be 0.9, so it will go to this particular service. The work of this service is to delete this post, tell the user what was the problem, because we already have the data of, let's say, we have 5 categories, right? So if we are getting 0.9 in one of the categories, right, we can tell the user that, hey, it contained sexual content in it, so that's why this post was deleted. And again, we will increase the count by 1. What this count is? The number of violations a particular user has done on the platform. Okay, then comes the second service, which is demoting service. Now let's say the score comes out to be 0.8, so we will pass this post into a demoting service. Why? What is the task of this demoting service? Is to make sure that this post is not reachable to a lot of users right now, because what we want to do is that we want to manually check once that whether this post is actually harmful or not, right? So what we are going to do is that we are going to stop the reach of this particular post for now, and make sure that it passes through a human annotator first. And if human says that, hey, this post is okay, the service of reachable, so to ensure that it reaches all the users, will be restored. And again, this data could be used for model training the next time. Okay, but if the post is harmful, then the post would be deleted. So this is the task of this service. Okay, so this is the whole machine learning system design of harmful content detection. Thank you.